I got that. Hi guys. Okay, you guys ready to start? Alright, what you guys see in front of you guys is the periodic table. You don't know it's the periodic table, but it is the periodic table. It looks different.
It's empty.
It's empty. What else?
This is this.
It has extra this and this. It's got extra this and this. We're going to look at the this and this components, okay? So when we're discussing the extra this and this, we're discussing this spot to this spot. Okay, you guys, so this is what's messed up kids for generations. Okay, first of all, we did not create the periodic table. We identified parts of it, and where those parts go told us how to make this. Okay? And I know that sounds really weird to say, but if we made something this jacked up, I would punch some scientist in the face. This is just how nature is. Okay, and we'll talk about this piece later, but we're going to take this piece you're not used to seeing here. From here to here are 14 spaces. So I want you guys to count over 7 of those. So now you guys will be right in the middle of that. And we are going to attempt to do our first fold. That's why this dotted line is here. Okay, because you guys are going to fold, and I will demonstrate up here. Okay, so look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You guys are going to fold right on that 7 one. Okay, and you're like, how are you even folding that? If you look at the back, you can see through the paper. Okay? And so you should make it to where you have 7 blocks on 7 blocks. And then oddly enough, it'll make the rest of your tall towers there static. And so what you guys have now is if you guys have it folded over, you guys should be able to see like from here to like here, you should see the right side of it, but everything else will be blocked. Okay? Now for many of you, you won't know if you folded it right until we do the next fold. Okay, so I'm going to walk around like this and let you guys see. This is my periodic table. If there are any like it, then this one is mine. That's a huge logo. Full metal jacket. Get up and say periodic table. Okay. Alright, so now once you guys have it this way, one of the ways you'll know if you're right is we're going to fold it back 3 blocks. So what that means is if you guys turn it back, if you make a fold right here where there's 3 blocks, and for those of you guys in video world, you're going to make a fold right here. See how there's 3 blocks? Okay? You're going to make a fold right here. Okay? So when you do that, does this look more like the periodic table you're used to seeing?
Yes.
Yes. My favorite quote of the day is second hour attempting to fold this. Kid attempts fold 7 times, looks at me and says, can we just do more dimensional analysis? I was like, dude, really? That's how you feel? Alright, so when you guys get this folded, you guys should look and see that this looks more like the periodic table you're used to seeing. And speaking of periodic tables you're used to seeing, you guys could open the very back cover of these textbooks. There's like one for every 2 of you guys. And then you look at it and go, oh yeah, that makes sense. This looks a lot more like the one I'm used to seeing. Okay? What you talking about? Alright, we're going to go on this one. Awesome. New fold, new fold.
What?
Okay? We are now going to flip the bottom of your page up. So you're going to fold up, and you're going to put the bottom of the page on the very bottom of the periodic table. So as you fold up, you should just barely be able to see the bottom line of the periodic table. Yeah, very good. It's very good. Very nice. Alright, you guys. What's really cool now is I'm going to show you how to put your name very nicely on the back of the page. When I collect these, I expect to see your name, and I expect to see you guys with the number 4 after it. Why? This is 4th hour, okay? So, here's the deal. Do you see this little tiny spot? I want you guys your name like so. And you guys are like, Mr. Moore, you just told me to put my name on the back of the paper. Watch this. Make transformer noises. Oh, look. Your name's on the back of the paper, okay? When I do collect these from you guys, I'll be able to stack them nicely this way. So I'm gonna go back, transform it up. And this is where your name's at, okay? I'll walk this around.
Oh, okay.
Cool, if you guys have space, I'd also like you to write supercalifragilisticexpialidocious. No space? Okay, cool. Okay, so speaking of spacing on this, when I ask you guys to fill things in, you guys are going to have to write pretty small, okay? There's going to be times when I zoom in on my paper so I can put the details I want. You guys just have to understand that I need you guys to write small, okay? And so when I say small, each of the boxes on this for the periodic table are 2 centimeters by 1 centimeter. Okay? Your big boxes on top, there's 2 of them, they're squares, they're 4 by 4 centimeters. When I ask you to write, most of the time I want you to write either a half a centimeter tall or a centimeter tall. Okay, and you guys will just have to like do some judgment calls on how you guys write on there, because by the time you get done, this is gonna look like science class on crack. Okay, does it make sense to you guys? Okay, alright, now, next fold, I want the big boxes to go away. So what you're going to do is you're going to fold right along the bottom of your big boxes and fold it backwards. Okay? And you'll just leave the top of your periodic table. This is what? This is, well, making it soothing. We're skipping the part of soothing. How many of you guys like to measure things accurately? It sounds dumb, but drawing these things out with big old intersticks and rulers is really going to be fun. So if you guys look at it from the back now, you'll see your squares. If you look at the front, all you'll see now is your periodic table, correct? Okay, very good. Also, you guys, this is also the equivalent of a 100 level college class on origami, and this will be a swan when we're done. Okay, also not true. Oh, I mean, it'll fly. You guys will crumple it up like a ball after it's graded and throw it in the trash. And then you'll realize that was a lot of work, and you'll get it out of the trash, straighten it up, and put it up on your wall. You guys, students come back and talk to me about things, or email me and talk about things, and they say thank you for 2 things. You guys will laugh. The first one is outlining, and you will all hate me because by the time we're done with the next 3 or 4 weeks, we're outlining a ton. But you guys will be so good at it that I have students who show up to college, they're talking to their friends in the parking lot. Okay, do you guys see the fold I made on the side? Okay, so basically now we're getting closer to just having a periodic table up here. Okay, they get to the parking lot, their friend says, are you ready for the test today? And they say, what? And they get out a piece of paper, and they outline the chapter, and then they run into class, and then they stare at that outline for 5 minutes, and then they pull a D on the college test. And they're so thankful that they learned how to get information out quickly. I don't want you to make that your college plan, okay? But you guys will find out that in college in a semester, you're lucky if you have 3 tests. You usually only have 2. And I say you're lucky because some college classes are only off the tests. So you have a midway test, and then you have a semester final. That's it. So the skills I'm teaching you, that's one of them. This periodic table is the other thing that kids always come back and say, hey, I lost my ridiculously stupid periodic table. Do you have a picture of one I can have? And I give it to them. And then they take it to their college friends. Their college friends make fun of them for being dumb, much like you will make fun of me for being dumb while I teach you this. But, dude, this will help you understand stuff. Because before, I didn't understand that this was the periodic table. But now you guys can see, it's a table. Periodic table. You guys are like, dude, I seriously folded it this way to make it look like a table?
Wait, what?
Yeah, why are we?
Isn't that amusing? Well done. Now you know everything about chem. Okay. No, I did it this way for 2 reasons. Okay? The first reason is storage. Now you can put this in any of your books, you can put it in your computer case, you can put it wherever, and now you have this. So don't lose this for the next couple of weeks. I say a couple of weeks because we're going to do this all week next week, and then we're probably going to do 1 or 2 more lessons after break. Okay? So you guys need to hang on to this. Okay? The other reason I did this is to explain how the periodic table works. Because what you're looking at right now fits in books. Okay, and that's a huge component for getting the periodic table done. Now we're going to unfold it. So we get to use the full lines as references. Okay?
Why are we portraying
Art and stuff. Alright guys, here we go. Welcome to 6th grade. We're going to knock out 6th grade in about 10 minutes. 6th grade atomic unit probably took you 3 weeks. Okay, let me just go back in time. You probably had a lecture where you just stared at your desk, okay, didn't learn anything. And then you probably had an assignment or an activity where you had Play-Doh or marshmallows and you like stuck things together and you're like, it's an atom. And then you maybe did like a poster or a drawing of an atom and all its parts. Some of you in hardcore classes probably made the atom out of like a coat hanger and some little fuzzy little artsy balls or something, right? No? And some of you guys are like, nothing. Well, your teachers suck. Okay, we're gonna move on. All right, but here's all the review you need, all right? Here is where we're working. Okay, so by the way, when you folded it, you guys, you should only be able to see this spot, this spot, this spot, and this spot, and everything in between. That's what we just set up. Now we unfolded it, we're gonna work in the top left corner, okay? And I'm gonna try and zoom in so I can give you guys a little more detail, because if I'm writing on this paper, you guys need to keep it in perspective, because the words I'm gonna write are gonna take up like this whole space, and then maybe this space over here, okay? Not much more. So I'm gonna zoom in now. I don't want you guys to get crazy and write giant. Oh no, I don't. Okay, here we go. Also, you guys, there's color pencils. I would start with just a pencil when we put these names down, but once we get past names, I would like you guys to use some color. Or if you want to get crazy, you could draw your atomic man with some color. Uh-oh. Uh-oh. Can I move this over? Uh-oh. We're going to leave it just like it is and not zoom in for this recording, so you guys have to listen while we go. Ready? All right, so here we go. We'll go black. All right, so this is going to be labeled atomic structure, so it's going to look like this. Atomic structure.
All around, all along the bottom.
All in this little box. You're like, that's tiny. Yes. Most letters you're going to be writing right now should be 0.5 centimeter tall. Okay? All right, and then I like to draw my little atomic structure guy. My atomic structure guy has a fro. That's my fro. Why does he have a fro? Because I'm jealous. I want a fro. He also has some cool shades. And he's got a pick for his fro. Okay? That's atomic structure, right? You guys didn't think you were going to learn anything today.
Oh, I see it.
Ha ha ha. Alright, so let's talk about what I just drew. Okay? Alright, so first of all, our first word up here, we're going to write electron cloud. So I'm going to write electron cloud. And I'm going to draw a little arrow down here too, right there. Because that, my friends, is the electron cloud.
What is the other eye? Is that
Okay.
the other side?
Well, we have a plus sign and we have an empty sign. And then what's that guy up there? A negative sign, right? So we have our electron cloud. Everybody lives together in the, what's this thing that holds these two guys? Nucleus, very good. This is why I normally zoom in so you guys can see my words, but I know you can in the back. But this right here says nucleus. Okay, we have an arrow to this, arrow to the center. Okay. We have another arrow down to this guy with a plus sign in the middle. What's that? Proton. Okay. And then we have an arrow down to this guy right here with a negative charge. What's that? Electron. Okay. And then we have an arrow to this kind of eye right here. And this is the neutron. Okay, here's the neutron. Okay. Is that atomic structure? That's pretty much everything we expect you guys to know in 6th grade. Now, if you had an advanced teacher who said, well, now you have to take and make your own atom, they probably taught you a little bit about the periodic table, at least enough to read it, so you could find out what atoms are and how they're made. So let's do that. So we're going to come over here to this next box. You guys are going to label this one key. I'm writing like I don't know, maybe a centimeter tall, maybe a half centimeter tall. Okay. Key on this. You'll find that most periodic tables use carbon. Carbon's fairly simple, it makes for a good key. So we gotta have a couple things. First of all, carbon's atomic number is 6. Its symbol is a capital C. Okay, and then its number is 12.011. Okay, 12.011. Okay. Yes.
Do we need the name for carbon?
So here's the deal. Most periodic tables have the name, correct? Just to fast forward, you have to fill in all the boxes on this. Do you think you're going to get the name in there? No. Probably not. So for this particular one, we're not going to put the name, but yes, normally there's an atomic name. But in the past, when I have written carbon in there, I have gotten some train wreck atomic maps back. Periodic tables are just full of crazy writing, so we're going to leave that out, okay? But let's identify what we did put in there. Yes?
Do we need like the bubble or
If you just regular C, you're okay. All right. Okay, so here we go. We got this guy right here is number of protons. This is the number of protons. Okay, this tells us that there are 6. We know what the element is by the number of protons. So this is also known as the atomic number. Okay? This guy right here is known as the atomic symbol. I love it because I go back and do the 6th grade bit because you guys need to know all these pieces. And as after the kid wrote atom for the 3rd time in atomic what? Mass. When they wrote it the 3rd time, she goes, "Hey, the word atom is in all these words." And I was like, "Yes, science." Okay. So you guys, this is the atomic mass. Okay. Now the atomic mass tells us the number of
neutrons plus
protons and neutrons. Okay, so this is the number of protons plus neutrons. And this is probably for you advanced 6th grade type kids. Bam! You guys learned this and you're set. But we still got to jack with you. So there's another name for this. Okay. This is the molar mass. Okay? This is the molar mass. Okay. This goes back to dimensional analysis. Fun story. I taught you guys dimensional analysis. And sometimes we went from grams, okay, to like, we used its Avogadro number, right? We did all that mess. We don't call it dimensional analysis in chemistry. We call it stoichiometry, okay? If you guys tell some of your friends or family members or whoever who know anything about chem that you're doing stoichiometry, they're going to say, "Oh, are you in junior chem?" No, you're just at Steve's. Suck it up. Okay, next. Okay, all right, so you guys, this is where we're going to get our molar mass, and that's going to help us when we do our dimensional analysis. Or stoichiometry. Okay, stoichiometry. Okay? All right, cool. So we got that set. You guys now know what atomic structure is. You can pass 6th grade. You now know how to find it from the periodic table. You can get an A in 6th grade. And now we're going to talk a little bit about the periodic table. Okay? So first thing we're going to talk about is how this is built. Now, history of this, these guys had a few elements. They knew what a few of these elements were, and they studied the heck out of the elements, and they learned things about electrons and protons and how they combine with other things. They learned enough to know that they didn't have all the elements. When they started to make this, there was all these empty squares. We're like, we need something with 27, gotta find something with 27. We know there's a 27, and then boom, someone discovers 27, they fill in the hole, okay? It's genius because this is built in by the periods, which there's 7 periods, okay? And we're gonna draw this fun little guy. I'm gonna do colors now. Whoop, whoop. So you guys can do colors too. We're gonna go Lelo on this one. Okay, and I'm gonna start about here. And I'm gonna go whoop. We couldn't decide earlier if this is a netter or if it's a lumber. Because it's a number letter or it's a letter number. What number letter is this?
7.
This is lumber 7B. Could be Pevin, could be C. I don't know. Okay, but why is there a 7P on here? If there's P on your periodic table, I blame the cation. Okay, we're gonna move forward. Okay. All right, so there's 7 periods. So I'm just gonna write them right here. 1, 2, 3, 4, 5, 6. You go to 1 patriotic assembly, you start counting like this. No, sorry. 7, 10. All right. All right, so now we have our periods. 1, 2, 3, 4, 5, 6, 7. Now, once again, you're thinking, why the heck would a chemist just decide to use the number 7? We did. We found out that there are 7 orbitals, that's these things that we have on the outside. So earlier I taught you 6th grade, hey, it's an electron cloud. Now I'm going to teach you about orbitals or levels. There are 7 levels where you can find electrons outside of the nucleus. The first level holds 2 electrons. And look, 1, 2. Okay, we have a spot here, and we have a spot here. That's the first shell. Next shell, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 2, we have 8, we have 8, then we have 18, 18, and then we stay at 18. We'll talk about that in just a second. Okay, here we go. So now we have our P7, which tells us 7 periods. Okay, we have to talk about the bottom here. I would like you guys to fold this to where you just have your normal periodic table. Fold this line here, so I want you to fold this one back close, and then I want you guys to fold the line that runs right here. Okay, this guy I want you to fold as well. Okay. All right, now that it's folded, like so, you guys have this guy again. Okay, this is how I want it folded. All right. Now, this is a shout out for my little G's. Okay, we're gonna put G on here. We're gonna put the number 18 here. Why would I write an 18G on this? There's 18 groups. So before you start sketching this, you might have to take time to make fun of me and then sketch it. But remember, my paper is not folded. Okay, so my drawing's gonna stop right here, and it's gonna start up again over here. Okay. So underneath here, I leave space because later I'm going to want to go 1, 2, 3, cross. So here we go. Ready? So I go, here's my 1. And then here's my 18. But the top of my 18 is funny shaped. Okay?
At this time, could I please have all students who have third lunch go to the lunchroom? All students with third lunch, go to the lunchroom now. Thank you.
I know our bellies are full, but doesn't it make you want to go to third lunch?
Yeah.
All right, so it kind of goes here and then starts up over here again, and it comes from here. to Here. Okay? Now what's funny is you guys will see on mine that it looks like this, and when I open it up, I went ahead and filled it in. Okay? So you guys can go ahead and fill it in. But I want you guys to be able to close it and look at where I draw my 1 through 18s. Okay? Cool.
Can you show
Okay.
us that on the whiteboard?
Can I show it on the whiteboard?
Yeah, like how to draw that G part.
Haha, you want me to make it bigger? Yeah. Here's my G. And that goes far away. Squeaky, squeaky. Okay, does that make sense? Then it'll end up way down here, like this. Okay, and then when you open it up, you're just gonna finish those lines anyways. Okay? More better? Cool. So when you guys fold it, you guys will have those linked. So how many groups are there? 18 groups. Okay. So when we talk about this, we're going to talk more in depth later, but I want you guys to know what's up. You're still wondering, like, hey, there's this periodic table that looks like mine, and then there's the one in your book that has this big missing space. Okay? With this big missing space, here's the deal. shortly after we figured out this chemistry stuff, we just moved from alchemy, which was like, it's magic, but people were tired of getting burned, so they're like, I'm a pharmacist, I'm not a magician. Okay, so instead of doing alchemy, we just did chemistry, and they figured out this periodic table, and everything was great. And then they came up with the printing press. And when they had the printing press, they couldn't get the periodic table small enough when you left it like this to go in a book without everything being too small to read. So they decided to take a huge chunk out. So when you guys fold it closed, the chunk that's missing is two groups we'll talk about on Monday. Yeah, Monday. But they're pulled out because they all behave like group 3. So identify group 3. Hey look, it's group 3. All of these guys from here to here behave like group 3 elements. So when they couldn't figure out how to make this fit, they just took it out and put that chunk on the bottom. Okay? But it belongs here. Cool? Yes. Alright, cool. Now, this sounds dumb, but I want you guys to know that in my epic life of failing, because I failed at a whole bunch of things before I got good at them, one of the things I failed twice was chemistry. Okay, and I want you guys to know no one took the time to tell me why this is set up the way it is. I want you to understand that I'll refer to this as my atomic map, because once I teach you how to read the map, you can find anything on this and you can solve all your problems chemically. Okay, and that sounds funny, but for a lot of you guys who are going to go into a chemistry major or a chemistry minor, this is going to help you out a lot in the long run. Okay? Alright, so check it out. So now you need to understand that we stack them by numbers. So we have the numbers are based on protons. So this guy right here, okay, ends up being number 1, right? Okay, and what's its symbol? H. And then somebody tell me its mass. 1.0069, you said? 79. It's going to be really hard to make it all fit on this, right? The fact I can't zoom in makes me a little bit crazy right now. But, alright, so you guys understand that? This 1 looks a lot like a 2, doesn't it? We're going to have to fix that. There we go. Is that better? Yes. Okay, so you guys, when we stack this up, they went 1, 2 over here.
At this time, all students should be in their back
then they went 3, 4, okay, 5, 6. These guys are all period. The first guys, hydrogen, helium. They're both period 1. Then these guys below it are period 2. We go down 7s. These guys on this end are all called reactive metals. We'll talk more about them later. These guys are all group 1. Okay, so this is how they set it up. All right. Now, the other thing that happened when they set it up this way is they're just identifying patterns. Patterns upon patterns upon patterns. The patterns here are periods and groups, but there's also an atomic size pattern. Okay? So, go ahead and close them up again so they're folded. Okay, so you guys should have it like this. And I'm about to add 2 size indicators, okay? There's one size indicator that runs across the top and then down like this. And there's another size indicator that runs down the side of the page here and over here. So I'm going to draw those on the board for you. Okay? So we'll do this one first because it's a little easier. And we'll make this green. You guys can make it whatever color you guys want. But we're going to start with a line right here. Okay, and it's going to go down to about here. So we just roll down this way. Okay, and then it's going to end up right about here. And so we go like this. Okay, all right, and we're going to write atomic size. Okay, and down here we got a big. And up here, we got low. We'll put low over here. Low. Okay? So we got big and we got low. Okay? Now across the top, you're going to want to leave just a little bit of space so you can write atomic size. So I'm going to drop down like maybe a centimeter on this one. Okay, so I'll put a dot right here. Notice I'm just above the end of hydrogen here. And then I'm going to go up about 2 centimeters from hydrogen to like here. Okay, so I got 2 dots here, and then I'm going to put another dot all by itself about, once again, 1 centimeter down from the top of the page, like right here. And then you guys can grab a ruler, you can use the side of your paper, you can use the side of your book. But yes, the ones on the side, this one here says big, this one here says low, and this one says atomic size. Okay, so now we're going to do the same shape up top. If your paper's folded, you're gonna have this big skip, and that's okay because we kind of want to skip there for later. All right, so you're gonna come to like here where your fold starts, and then here where your fold ends. Okay, and then you're gonna go from here to this one. Now mine's gonna look a little weird because if I go straight across, it's not gonna line up all right, but we'll be okay. So you'll notice that I'm gonna put it here. I get to my key and I kind of stop, and then I get to here, and then I finish it out from here to here, so that when I close it up, you can see this. So I'm gonna write big right here, okay, and I'm gonna write little right here, right, and then up here I'm gonna write atomic size.
Wait, why did you make that skip?
Because it was folded. I can't fold my Promethean board, right? So you don't have to skip if you guys have it folded, right? Just do your stripe, zip, zip. Okay, unless you prefer to zip zap, that's fine. Don't go zippity zap. That's just too much. We need to keep it together. Okay. While you guys are writing, it's just funny. Where do atoms go to church? They attend mass. Catholic kids get it. We'll move on.
I can't see.
What's up, John?
I can't do writing this small.
What? That's impossible. I normally zoom in. Sorry about that. This says big. This says low. This says atomic size. Okay? This says atomic size. This says low. This says big. Got it? Okay? And you guys will notice it matches the shape that you drew. Right? Now, crazy concept. This is a big end, and then this is the little tiny pointy end, right? And this is the big end, and this is the little tiny point end. If we were talking about this atom that lives right here, if on our periodic table we just put pictures of the atoms, would this be a very big atom, or would this be a little atom? Lil. This would be classified as lil. That's not a real classification. But if you look at the one that you just drew down the left side and the right and the top, you have little. That makes this the smallest atom. Where does the biggest atom live? Very good. I saw lots of hand signals, and I heard the big. Very good. We got big, and we got big. This is our largest atom. Okay? So what's really funny is, once again, we did not make up the periodic table. We just kept discovering things, and as we learned things about the atoms, we put down the information. And despite this looking like the worst castle that a 5th grader ever drew, okay, this is genius, because it shows us periods, which reflect on the electron shells, which we'll spend the whole day talking about that, and it tells us groups, which tells us how we group down, and we'll learn more about each group, but this group is very violent. They like to give away electrons. This group over here, they like to take electrons. Okay? And then there's a group on the end here that we'll talk about on Monday. Okay? I'm gonna look at my notes real quick because I think there's just one more thing I have to teach you. Okay, and it's a little bit about the periodic table, but it's more about what you guys have learned. Okay? You guys get these notes down? Okay, ready? Here we go. We just have to talk about this real quick. We have hydrogen sitting right here, right? What is our atomic structure? What did we draw? Just look at it. What did we draw? We drew an atom. What atom is it? Hydrogen. So real quick, we have to talk about this because, so I'm going to draw this in black, but then I'm going to cross it out and draw the real name because you're all wrong. Okay? This is hydrogen. Okay, and I'm going to put a question mark after it. What? Okay, now, we've been taught this hydrogen. It's a very simple one to draw. Many of you probably chose this in 6th grade because you're really smart kids and were like, dude, if I pick hydrogen, I have like no work to do. But your project was probably wrong, and your teacher probably gave you credit for it anyways, because we don't want to blow up little kids' heads. But I want to point out a couple things to you now that you're big kids. We'll say young adults. Yolts. All y'all yolts. Okay, we'll move on. Okay. Hydrogen. Why would I say it's hydrogen? It has 1 proton. Okay? But now let's look at what we drew. What we drew has 1 proton, 1 neutron, and 1 electron. Okay? I want you to know that's weird. It doesn't seem weird because it makes sense on our drawing, but let's look at this. Hydrogen. Atomic number? 1. How many protons? 1. What's its atomic mass? 1.007. How do we find out the number of neutrons?
Atomic mass minus
Okay, so do it. Atomic mass, 1.00079 minus 1. What's left over?
0.0007.
Okay, you guys, so this thing that we made doesn't exist in nature very often. Okay? Normally, when we find a hydrogen, okay, it's got one proton, it already gave away its electron, and it doesn't even have a neutron. It just rolls by itself. Okay? So what's funny is what we drew up here is deuterium. Deuterium. Get ready to write. I'll spell it out for you guys, okay? Deuterium. So just below it, I'm going to write it in red. You guys don't have to change because it's a fancy word and you might have to write it nicely. So deuterium. So it's D. Oh, didn't make it red. You guys are a little off on this side. Okay. Here we go. So we got D, E, U, T, E, R, I, U, M. So I'm just gonna like lightly cross out hydrogen. Maybe. It'll let me. Okay. And it now says deuterium. Okay. Now the reason that's really important is you guys have been taught about the periodic table. You've been taught about atomic structure, and we've taught you the best we can so your little heads don't explode. Okay, but now you're gonna have to find out as you're older and you're putting these pieces together, you're gonna be like, that ain't right, that ain't right, that ain't right. You're gonna point at things that you used to learn, and you have to be able to think it out. Okay? You need to be able to look at hydrogen and understand that its atomic one is 1 because it has a proton, but because its atomic mass is 1.00, who cares, that's super small, it doesn't have a neutron. You have to be able to think about that, okay? And knowing what we know about electron transfer, which we'll talk a little bit more about in later lessons, you need to understand that this is actually deuterium, okay? When you look at something that has a big dumb name, and you're like, why does it have a different name? It looks like this to me. You're gonna have to start using your periodic table to tear that thing apart and decide what you think it is scientifically, okay? I'll pass out some funnels. They're small funnels in the back if you guys need to put your brain in your ear. Just scoop it up off the table. Okay, you guys get to go on this mess? Okay, good, great, grand, groovy. All right, cool, guys. That was 6th grade and some.